Hello all, welcome back to my STL series, and today we are going to see how do we solve problems using pairs, and is there a better way to write code than using pairs, because in some cases it can get a little unmanageable. So anyway, let's try to state our problem first. So our problem statement is that there's a 2D two-dimensional plane, and we have to insert. There are many two-dimensional planes actually, and they are represented by x and y coordinates like 1 comma 2, 1 comma 3, 4 comma 5, 6 comma 7, and we need to gather all this data inside a list. So how do we do it? So the thing which comes to our mind is that we will take a vector of pairs points, and we will do something like this: parent p1 equals 1 comma 3. Let's say we have to insert points p1 is 1 comma 4 and point 2 is 4 comma 5, right? So we can push back point p1 and we can push back point p2, right? So this is fine. So far so good. So far, in fact, so far not so bad. But imagine if our requirement changes, and instead of this being a 2D plane, we are now required to uh, store the data of a three-dimensional plane. So how are we going to change this code? So if you want to change this code, you have to change the whole structure like this, and this is where things will get a little tricky. Wait a second. Now imagine if my points are like 1 3. Since now we have a three-dimensional plane to deal with, so our plane will have values like x comma y comma z. So the values will be like 1 comma 3 comma 10, 4 comma 5 comma 0, 6 comma 7 comma 12. Now how are we going to define our pair? Can we write something like parent int? No, right? We cannot write something. We cannot write anything like this, like, because pair only takes two values here. Like, it should be an int and it should only have one other value. It can't take three values. So what we usually do is, like, we take another pair int, okay, and then we try to push the values. So at this point itself, you can see that things are getting a little tricky. Now imagine if this point is about a four-dimensional plane, so x, y, z, a. So this will become even more complex. Like, instead of this int, I will have to write pair of int and int again. Now you can just see this code, and this looks so messy, and I might be even missing some angle brackets. I'm not even sure that those angle brackets are balanced or not. And how are you going to access? Let's see an example. Let's see an example of what a 3D pair looks like. So let's say if I have something like pair int p1 equals 1 comma 3 comma 5. So can we write, if you have to access the first element, can we write something like, wait, p1 dot first? Yes, we can write it, right? But for the second element, can we write something like p1 dot second? No, we can't write, because the second element is itself a pair. So first element is an int, so we will get the first data. Second element is a pair, and to get the coordinate of the second dimensional, we need to write something like p1 dot second dot first. Similarly, to get the third dimensional, we have to write p1 dot second. Now you can, so, and this is just a three-dimensional pair. Now you can imagine the mess we will have when we have four dimension, fifth dimension, and I mean, we cannot just, it will be way too much to handle, and debugging it will be very, very difficult. So is there a cleaner way to write this? In fact, we have, which is why I'm making this video. So you can, we can use the struct data type. Let's say struct point int, and I'll tell you one more reason why I'm using struct xyz int, and we do something like we do some constructor x2 x3 no y1 z1. So x equals x1, y equals y1, z equals z1, right? So now you see that this is a constructor of this structure, this point structure, and this takes in the x1 variable, y1 variable, and z1 variable as parameters, and this sets the values. So now let's define a vector of point. You see how clean this is, like you're just defining a vector of point. You don't need to define a vector of pairs or pairs of pairs or anything like that. Points. So now we have a points vector which contain point, the point struct. Now let's try to declare a point p1 equals, you can see how simple this is. Let's say if I have to have this point, if I have to represent this point, how will I do it? I'll just do 1 comma 3 comma 10, right? Then point p2 equals point 4 comma 5 comma 10. Now compare this with the one which we had the last time. We had a pair of pairs. In fact, I just pulled this up, the code which we had posted the last time. So this is the one which you get when you are using pairs of pairs. You see how this looks, and you see how clean this looks. Now if you can do something like points dot push back p1, points dot push back p2, right? Now you can easily traverse this auto of points function and like print x1 x. So this x would be corresponding to like each of the point in this points vector. So this x will basically copy the individual elements. So now we can access, in fact, let's try to access, let's take it like current point. So for current point dot x, current point dot y, and current point dot z, and then end of line. Let's try to print this. I hope this doesn't give me a compilation error. Okay, let me comment this out, and hopefully this will run. Yes, now you can see that it's printing like 130450. So just to summarize, we started with having two dimensions. So let's say if we had a two-dimensional, if we have to represent a two-dimensional plane, we can use we can use a pair. But as soon as the dimension grows, we will have to have structures like this, pairs of integers and pairs of it, which can get very complex very fast. So to overcome this, we started to use struct data type, where we declared our own struct data type, and we had our own set of variables. We even had a constructor which we used to initialize this, and yeah, you can see how we pushed it to vector, and then we printed it, and we can use it as a when we wish. So I hope this was helpful. I'll be uploading this video. Thanks, goodbye, take care.